Good morning, guys. So what we're gonna do here is we're gonna quick lesson today, not too long. We're just really trying to practice this idea of slope, and the best way to do that is to really look at it in the context of real world equations and scenarios. So we're gonna talk about a climber who's on a hike. All right. So you've got this in front of you. Follow along with me here. We've got a climber on a hike. It says 2 hours into the hike, he's at an altitude of 400 feet. Okay, that's important. 2 hours into the hike, he's at an altitude of 400. Then 6 hours into the hike, after he's been hiking for 6 hours, he's now at an altitude of 700 feet. And the question is, what is the rate of change between those 2 points? Now, what you'll notice when you look at the solution, this is the part that we're giving you the answer, right? Is they are taking what I have underlined here in red, the 2 hours and the 400 feet, and they're creating that as a coordinate, 2 and comma 400. So what I want you to see here is this, that those two go together. And the main thing I want to point out is the fact that your time is always going to be your x coordinate. Time is always going to be your x coordinate. So really want to make sure you're very careful there that time is always x. Don't go 400 comma 2. It's 2 comma 400. So in the same way, we look at our next point. Our next point was 6 hours. So that's 6. And then our altitude is 700. So 6 comma 700. So then we use our formula that we learned yesterday. We're going to go ahead and set this up. We find the change in altitude divided by the change in time. So we use our same slope formula that you learned and hopefully will start memorizing yesterday. We're going to use that equation to set this up. So notice they took y2 right here minus their y1. So that's 700 minus the 400. That gives us 300. Then we took x2. So in this case, we'll call this one x2 minus x1. That's your 2 right there. So 6 minus 2. That leaves us with 4. If we divide 300 by 4, we're left with 75 feet per hour. And that's our rate of change. So this is a really important skill. We have this skill. We're going to assess it. We're going to test you on this skill, this unit. But the main thing is we see this skill a lot on the EOC, trying to use a real world scenario to talk about slope. Let's do one more example, go over one more example here, and then we'll let you guys start practicing. So here we have a table and the population, the year and the population of the city. Okay. So we can say in 1980, there were 20,000 people in the city versus 1995, we're down to 9,500 people in the city. Okay. So in the same way, we're going to set this up. And the question says, how do we find that rate of change? Well, what you'll notice is that they're picking two random points here. The change is the same. So I want to actually point that out before we get into the math. The rate of change here is actually the same. We are increasing by, I'm going to give myself a little bit more space here. Okay. We are increasing by 5 years every single time. So every 5 years, our population is actually decreasing negative. So it's going down. Write this in yellow so you can see it. Negative 3,500 people. Every 5 years, our population is decreasing negative 3,500. It's going to be the same thing again. If we go another 5 years, it's going to go down another negative 3,500. That's your rate of change. You may not see it, but it is constant. So the way we calculate that is you can see they started with the 1985 to the 1980. You could take y2, this was your y2, minus y1, all over x2 minus x1. So when you do that, you end up with negative 3,500. 1985 minus 1980 is 5 years. So that's 5. And when we divide, we're left with negative. This is important. Negative. I'm going to rewrite it here. Negative 700. Negative 700. I can't emphasize that negative portion enough. But it's negative 700 people every single year. Now, here's the thing. The negative doesn't mean that we have somehow negative quantities of people. You can't have a negative number of people. So the question is, what does the negative actually mean? So that's why this last piece here is so important. I want you to underline or highlight whatever this is. The negative part of our slope actually means that our population is decreasing. So not only does the slope or the rate of change give us a number, it also tells us whether whatever the context is, whether it is increasing or decreasing. So if we go back to our climber, his slope was 75 feet per hour. So what did that mean? He actually means that his altitude, the altitude of the climber, is, because it's positive, it's increasing, right? It's increasing 75 feet per hour. It's so important to identify the sign of your slope, because negative means something is decreasing, positive means something is increasing. Okay, so those are your first two examples. Try to get us wrap our minds around what's actually happening. We're going to do one more video to help you kind of practice some of the first two questions, and then you can try the rest on your own or with a partner. Keep up the good work.